So the degree measure of minor arc DE, we need to know what percentage of the circle this is, or what the angle is that generates it. And so maybe the angle is the easier way to think of it. So if we have the center of the circle here, this is a radius of the circle, and this is a radius of the circle, we need to figure out what this degree measure is. So let's see what we get. Triangle ACB is equilateral, statement 1 tells us. So that tells us that this is a 60-degree angle, and this is a 60-degree angle, and then this is a 60-degree angle. What that means for us is more than what it looks like. It tells us when you draw a line from the center of a circle to a line tangent to a circle, that automatically creates right angles. What that means now is that we have a quadrilateral, this quadrilateral here, and we know 3 of the angle lengths. We have 2 that are 90, 90 plus 90 plus 60, which tells us that the remaining angle must be 120. So statement 1 is actually sufficient to tell us that that the arc measure is 120. We cross off B, C, and E. Statement 2 tells us that the radius is 8, so now we know that this measure here is 8, but without, there's no way that we can get from a radius measure to the angle measure without finding out some other information about some of the other distances involved here, or some of the angles. So, and we don't even have this knowledge that it's an equilateral triangle. So without that, statement 2 is insufficient, and it is statement 1 on its own.